Hello. In this video, we are going to go over expanding logarithms and put that into further practice. We have another video. Another student asked for these problems specifically, so we're going to cover these videos and we're going to see how these problems are solved. So the first thing we need to remember is how to expand in our expanding rules. Remember that the log of x times y is actually equal to the log of x plus the log of y. So those two statements are equivalent. We also need to remember that the log of x over y is going to be equal to log of x minus the log of y. So numerator minus the denominator. And then lastly, we have log of x with an exponent. And what we're going to do with that exponent is we're going to bring that exponent right to the front, just like that. And we are good to go. So those are the three situations where we're going to expand. When I see multiplication, I'm going to add. When I see division, we're going to subtract. When I see an exponent, that becomes a coefficient. Simple. Okay, let's jump straight into this. Number 7, log base 6 of x cubed y to the 5th to the square root. The first thing we're going to do is rewrite log base 6, and we're going to put that square root in an exponent. That way we can see things a little more clearly with these rules. So now I see I have an exponent. I'm going to push that exponent to the front, like we know according to our third rule. So I rewrite 1/2 log base 6 x cubed y to the 5th. Next, I see there is a multiplication here. Since there's a multiplication there, that means I know I'm going to separate and add. Be careful because that 1/2 on the outside needs to apply to both of them. So we're going to put these in parentheses and or brackets, whatever makes you comfortable. So that x cubed times y to the 5th becomes log 6x cubed times log 6y to the, let's, make that neat, log 6y to the 5th. So that's important there. Okay. Next, we see we have exponents still, and we need to push those into the front next. Okay, let's go for it. We have our 1/2 on the outside. We will write this as 3 log base 6 of x plus the 5 goes in the front, log 6y. Beautiful. Lastly, we're just going to distribute our 1/2 and we're done. We're going to write this as 3 over 2 because 3 times 1/2 is 3 over 2, log 6 of x plus 5 over 2 log 6 of y. And we are good to go with expanding that logarithm. So let us apply those rules one more time for number 8. Number 8 looks a little tricky, doesn't it? Number 8 doesn't really show us a multiplication, a division, or an exponent. What it shows us is a subtraction inside the argument. That subtraction needs to be separated by logs if I want to rewrite it as one log, not inside the argument. That doesn't work. So what I can do here is notice a GCF. I can rewrite this as log, pull out a 10 times x minus 3. I will make this a bracket just so it's a little more clear. So let's rewrite this one more time. Log, we're going to write a bracket, 10 x minus 3. That is what that turns into. Now I can see it's 10 times x minus 3. This times that. So I can rewrite this now, log of 10 plus the log of x minus 3. And that's as far as you can go with that. You cannot break this one down any further. That's it. It cannot go because it's not a division. The subtraction inside the log does not become anything. It just stays. And that's it. That's as far as we can expand both these logarithms. If you have any other questions or specific problems you would like me to do, please either shoot me an email or say something in the comments, and I'll be happy to make a video. Other than that, hope everyone has a great day.